Hello and welcome to another episode of Bite Size Maths, where we explain maths topics in small and easy to understand videos. Today we will be covering the topic of matrices, and specifically speaking, we will be covering the topic of transpose, minors and cofactors of a matrix. So let's get started. So the first topic of the day is transpose. Transpose of a matrix. So what is transpose of a matrix? So transpose of a matrix, let's say our example matrix is B, M cross N, then the matrix formed by interchanging rows and columns of B is called transpose of B. Transpose of B. This is denoted by B followed by a like this. So this will denote B transpose, B transpose, and it will be of the order n cross m because we are interchanging rows and columns. So let's see an example real quick so that it doesn't become like too complicated. So let's say our example matrix B is 4 minus 3 1 root 6 7 3. Now this is a matrix of 3 rows 2 columns, so order 3 cross 2. So now if we start writing the transpose of this, so if we start writing transpose of this B transpose, then this matrix will become 4 minus 3 1 root 6 7 3, and the order changed to 2 by 3. So this is how a matrix is transposed. Now there are some properties related to the transposes as well, which is property number 1. If you take transpose of a transpose, so let's say B transpose and then another transpose, you will get the original matrix. Property number 2, if you are doing scalar multiplication of any scalar with a matrix and then taking a transpose, it is same as taking the scalar and multiplying it directly with the transpose of the matrix. Property number 3, the transpose of the sum of two matrices is same as both matrices being individually transposed and added up. And property number 4, AB transpose is equal to B transpose A transpose. Pardon me. So if you are multiplying two matrices together and taking their transpose, then it will be equivalent to taking the transposes of both the matrices individually and multiplying them in the reverse order. So if you are multiplying them in the order A into B, then you will have to multiply B transpose into A transpose. If you are taking transpose, so now let's do one small example of stuff related to transpose. So our matrix A is 1, 4, 7, 2, 5, 8. Matrix B is -3, 4, 0, 4, -2, -1. Now we have to find A transpose, A plus B transpose, and third problem, find 5B whole transpose. So let's get started. So A transpose again will be found by interchanging rows and columns. So this was a 2 by 3 matrix. So this will become a 3 by 2 matrix, 3 rows, 2 columns. So A transpose will be 1, 2, 4, 5, 7, 8. So this is our A transpose, order 3 by 2. Now let's add A and B together for column number 2, which is A plus B transpose. So first let's add the matrices together. 3 minus 3 plus 1 minus 2, 4, 4, 8, 7, 0, 7, 2, 4, 6, 5 minus 2, 3, and 8 minus 1, 7. So now we need to take the transpose of this matrix. This will be equal to -2, 6, 8, 3, 7, 7. And 5B whole transpose will be 5B transpose as the previous property, and it will be equal to -3 into 5 minus 15, 4 into 5, 20, 4 into 5, 20 again, -2 into 5, that will be -10, 0 into 5 will be 0, and -1 into 5 will be -5. So this is the solution for all the three questions. Now, when it comes to transposes, square matrices can be defined into two categories with respect to transposes. Square matrices can be categorized as 1. Symmetric. This happens when the matrix's transpose is equal to the matrix itself. So if you let's say take the matrix of, if you let's say take matrix 5 7 4 4, take transpose of it, you will get again 5 4 4 7. So this matrix is symmetric because you took the transpose, the matrix came out same. Now, second definition is skew symmetric. In this case, matrix's transpose equals to -1 times A. So if you take a matrix A, take its transpose, and if you get -1 times A, or a scalar multiple of A with -1, then it is skew symmetric. And because of this property, because every element in skew symmetric matrix will have diagonal terms absolutely 0. So your diagonal terms will be 0 for a skew symmetric matrix. Otherwise this condition cannot be satisfied. So let's see. So we will have to take 0, 0 for a simple example, -1, 1. So this is a skew symmetric matrix. Let's take its transpose, which will be 0, 1, -1, 0, and this is same as -1 into the original matrix, 0, -1, 1, and 0. Let me write it somewhere else. Okay, wait, let me move the board itself. Yeah, that works fine. So now this matrix here is -1 times the transpose of the original matrix. Sorry, I just said it out of order. The transpose of this matrix is -1 times the original matrix. Hence, this is skew symmetric. Now, another property is this. For any matrix, for any matrix, basically for any matrix which is square, A plus A transpose will always be symmetric. And for any square matrix, A minus A transpose will always be skew symmetric. So these are all the properties related to matrices with respect to transpose, and I do not want to extend this video further, so we will cover cofactors and minors in the next video.